Hey guys, welcome back to my channel. In this video I'm going to be going over all of GCSE quadratics. I'm not going to go over quadratic sequences because that's more to do with sequences than quadratics, uses different methods. So let's get right into it. So what exactly is a quadratic? So you've seen linear sequences before, where you have y equals mx plus c, and that's just a straight line. A quadratic is a curve. So a quadratic is represented by this equation here, y equals ax squared plus bx plus c, where a, b, and c are constants, so they're numbers. And the simplest curve you have is y equals x squared, as you can see here. And if you have a minus sign before the x squared, so if a is negative, then it's just flipped over the x-axis. So it's reflected over the x-axis, it will be upside down basically. And again, like with a linear equation, the plus c is the y-intercept. So as you can see for y equals x squared, you have a plus c. So c equals 0, and you can see that the graph hits the x-axis at 0. So as part of your GCSE, you're going to have to know how to draw and interpret quadratic graphs. So drawing is pretty simple. They'll give you an equation, so like y equals x squared minus 2x minus 3 here. And all you do is just create a table. I would suggest have like an x and a y, and then for each x value, what would the y value be? So just sub in, say x equals 1, x equals minus 1, etc. And then you can draw that curve on, just drawing the points together. In terms of interpreting quadratic graphs, they could give you a graph like you have here, and you need to be able to find these three things. So the y-intercept, which is something you should already know by thinking about the y-intercept of a straight line, is just where the straight line would hit the y-axis. Same for this one, nothing different. So y-intercept on this graph is 0, minus 3. And the turning point, so this is a new term. Essentially, the turning point is that very bottommost point of this curve. Now, something you should know is that, say this was minus x squared, minus 2x minus 3. Obviously, the curve would be flipped around, and it wouldn't be the lowest point, it would be the highest point. So the best way to remember is the point at which the curve starts change direction. So this here you can see that at the coordinates 1, minus 4, the curve goes from going downwards to going upwards. So just remember that. So it's just either the highest point or the lowest point. But I think the easiest way is to remember just where the curve turns. So where it changes direction. That's why it's called a turning point. And roots. These are essentially just what we call solutions. So I'll go into solving quadratics later on in this video. But essentially the root is the x-intercept. So here you can see that the graph hits the x-axis at minus 1 and 3, and that's what we call roots. So with quadratics, what you can do is you can actually factorize them. What that means is you can rearrange them into two values, and when you multiply them together, it will give you this quadratic. To do that, we have to think about what sort of form we want to get it in. So the two factors will be x plus a and x plus b. So b could be positive or negative, depending. A and b can be positive or negative depending on what your final result is. And when you multiply out these values, you get that. So I'll go over expanding quadratics on the next couple of slides. But essentially, when you factorize it, that's the form you need to have it in. X plus a times x plus b. And for this particular question, we know that a plus b must equal minus 8. So if you can see in the expanded form I have here, ax plus bx is that middle bit there. And if you just factorize that x, so you have a plus b times x, and if you match that with the quadratic you've been given, you can see that the term with the x has a coefficient of minus 8. So that means that a plus b must equal minus 8. And also you can see at the end we have the a times b. There's no x values on that one, and the same value on the given quadratic is 7. That means a times b must equal 7. So that's what we have here. And we want to figure out the values of a and b such that they give us these values when we apply these functions. So, for example, we have 1 times 7 gives you 7, and that could be, so a could be 1, b could be 7, but then we have to also make sure that works for a plus b. So we need minus 8. So we need a to be -1 and b to be -7, because in this case, if we do a plus b, you will end up getting +8. You want to have -8, and therefore you just use -1 and -7 as your values for a and b. Therefore, your factors are x minus 1 and x minus 7. Now, a tip that I would give you is that whenever you see a question where it's that the plus c at the end is positive and the middle bit here, so b is negative, so the a plus b bit, you will know that the factors, so the a and b in the factors here, they must be negative, because when you multiply two negative numbers, you get a positive number. When you add two negative numbers, you get a negative number. So that's how you can think about that. So here's a harder quadratic because you have coefficients of the x squared one as well. And for this one, same process, but this time, one of the x values will be 3x, and the other one will be x. Because when you multiply them together, we want to get 3x squared. So here what I've done is, again, I've just done what I did in the previous slide. So a times b should give you 6, and a plus 3b should give you -11. So you can see already in this factorized form that I have here, that I put it as minus a and minus b, because I know that they should multiply to give a positive number and add to give a negative number. So that's the general premise, just as I said in the previous slide. So to get 6, a times b, so what I've done here is -1 times -6 gives you 6, -3 times -2 gives you 6. Those are two ways of getting 6. And for this other side here, a plus 3b equals -11, I've just subbed in these values. So because I can have a equals -1 or -3, I can also have a equal -6 and -2 if b equals the other two numbers. So that's why I need to sub in the different values to see which one is a and which one is b, which is very important here, because when you multiply b by 3x, you're going to get a different value compared to if you multiply a by 3x. So it's very important which one goes where to get that middle -11. So here I've just subbed them in. So -1 plus 3 times -6 gives you -19, so that's not right. Same for the other two there. And the correct one is -2 plus 3 times -3, and that does give you -11. So what that means is that b must equal 3. So the reason for this is because we want it so that when you multiply the value of b with 3x, we get a value that when we add it with ax, minus ax, we end up getting -11, and that's the only way you can do that. So now you might be thinking, this is such a long process for like 2-3 marks. How am I going to do this in the exam? The thing with these questions is it gets much easier to spot what multiples to use, what a and b can be. It just takes a lot of practice. So what I suggest is in these next few weeks before your first maths exam, just do tons of these practice questions and practice papers. That way you get an idea of the different combinations of numbers and how different multiples can add to different numbers, and it gets very easy to quickly just spot. So after a bit of practice, you can just look at a question and you'll know what the solution will be without having to sub in all these different values and look at the different factors. So expanding quadratics. As we said before, we have the factor form of x plus a and x plus b. So we can expand that, and the way you can do that is what I call the crab claw method. So you can see here with the arrows, it kind of looks like a crab claw. So it's a very easy way to remember. You just want to multiply every term with every other term in the opposite bracket, okay? So let's take x here, for example. I'm going to multiply the x by the x in the other bracket and the b in the other bracket. And then I want to go into the a, and I want to multiply that by the x in the other bracket and the b in the other bracket. And you just add all the values together. That's what the expanded form looks like. So when I multiply x by x, I get x squared. When I multiply a by x, I get ax. And then when I multiply x times b, I get bx. When I multiply a and b, I get ab. So that's the expanded form. And because I'm using a and b here, it doesn't simplify any further. But when you have a and b as actual numbers, you can just add them together and you'll have a plus b times x, where a plus b is just a number. So here's a question that you could get. expand and simplify x plus 7 and x minus 3 multiply together. So that's what it means. When you have these two brackets together, you do multiply them together. So here we're going to be using the crab claw method like I showed you, and multiply x by x to get x squared, and you multiply x by minus 3 to get minus 3x. 7 times x gives you 7x. 7 times minus 3 gives you minus 21. And then when you simplify this, that gives you x squared plus 4x somewhere minus 21. So like I said on the previous slide, you can just add that minus 3 and 7 together because they have the same power on the x value. You can't add the x squared on the x values because they have different powers. So that's something to remember. It's what we call collecting like terms. They're like terms because they have the same sort of x value. The power of the x is just 1, so you can add them. So here we have solving quadratics. Now the way you can solve a quadratic is you have to equate it to 0. And as I've done here, you can see that firstly what I've done is I've just factorized it. And for every question where you have a quadratic that you want to solve, you have to factorize it. That's the only way you can really find a solution, or the quadratic formula, which I'll talk about later on in the video. So for x minus 6 times x plus 3 to equal 0, either x minus 6 must equal 0 or x plus 3 must equal 0. So if x minus 6 equals 0, for example, then if you just multiply x plus 3 by 0, we get 0. So either one of them must equal 0. So the solution for x has to be 6 or minus 3, as these are the only two values of x. But when you sub them in, that equation there will equal 0. So this is what we call the quadratic formula. This is used to get the solutions for a quadratic when the whole multiplying and addition thing that we did at the start, the factorizing bit, isn't that easy. Sometimes you can have solutions that aren't whole numbers. So you can have surds, you can have decimals, you can have fractions, and you can't think of that on the spot. So this is the way you do it for harder solutions, when the solutions aren't just straightforward like 2 or 3 or something like that. So here is a question you could get. Solve 2x squared plus 13x plus 7 equals 0. Give your solutions correct to 2 decimal places. That's a very big clue as to the fact that you have to use the quadratic formula. If it says 2 decimal places, 3 significant figures, that's when you know that you have to use a quadratic formula because your solution wouldn't be a whole number. So what I've done here is I've just subbed in those values. So if I just quickly go to the previous slide, we have the form ax squared plus bx plus c, and you can see the quadratic formula here, minus b plus or minus b squared minus 4ac square rooted all over 2a. I'm just subbing in those coefficients. So where it says b, I sub in the number that replaces b. And where it says c, I replace the number that says c. That's essentially the gist of it. And so if you go into this question, you can see I've just subbed in the values for b, a, and c, a, b, and c, and that gives us minus 13 plus or minus square root 13 squared minus 4 times 2 times 7 all over 2 times 2. Now, that plus or minus symbol there, you might not know exactly what it is. Essentially, what that means is that you do this quadratic formula once where you have minus 13 plus square root, etc., and then you have that all over again where you do minus 13 minus square root 13 squared, etc. That gives us two solutions. These are the two solutions that we get. So I've just simplified what's in the square root. And that's why, like I said, we got the minus 13 plus root 113 over 4, then minus 13 minus root 113 over 4. And those are our two solutions. We just put that into our calculators, and that gives us these two numbers to 2 decimal places, and that's our answer. So you could get quadratic inequalities in your GCSE maths paper. These can be quite tough, but there's a very easy trick to knowing how to solve these. So we've got first ax squared plus bx plus c is less than 0. What that means is we'll just look at the part of the quadratic graph that's below the x-axis. So that's below y equals 0. And for the opposite one, ax squared plus bx plus c is greater than 0. We're looking at the part of the graph that's above the x-axis, so above y equals 0. It can also be less than or equal to 0 and greater than or equal to 0. But essentially, those are the parts that we're looking at here. So here's a typical question you could get. We're trying to solve the inequality x squared is greater than ax plus 9. First things first, you want to rearrange it so you have all your terms on one side and you have 0 on the other side. So you have x squared minus 8x minus 9 is greater than 0. And as you can see here, you can do it on the other side as well. So rather than moving 8x and 9 to the other side, so I've just subtracted 8x plus 9 from both sides. And that's what that gives us. You can also have minus x squared plus 8x plus 9 is less than 0. It will give you the same answer. Then next thing I've done is I've factorized it. And what this gives us is the two solutions. So if, for example, we equate it to 0, the way you can get equal to 0 with x minus 9 times x plus 1 is if x equals 9 or x equals minus 1. And because we're looking at greater than 0, that's the part of the graph that we're looking at. This is just a simple sketch. It's nowhere near accurate of what the actual graph looks like, and it doesn't matter what the actual graph looks like. All we're trying to think of here is, are we looking at the part of the graph that's above the x-axis or the part that's below the x-axis? So in this case, we're looking at the part that's above the x-axis. And therefore, the solutions that we get is x is less than minus 1 or x is greater than 9. So how do I get those solutions? So you can see this red highlight on the graph. Since those are the bits we're looking at, we want to find the values of x for which that graph is above y equals 0, so above the x-axis. And you can see here that the two roots that we got, the graph is above the x-axis for values that are less than the smallest root and greater than the biggest root. The smallest root we have is minus 1, and you can see that on the leftmost red line here. And essentially, any x value that's less than minus 1 will be above the x-axis, and any x value that's above 9, as you can see on the right, the red line on the right side, will be above the x-axis. So you can already see that the sketch I've drawn is nowhere near accurate because the first root is in the positive quadrant, and you can see that the actual root is minus 1, so it should be in the negative quadrant. But it doesn't matter because I've only drawn that sketch so I know which part of the graph I'm looking at. So here's another question. Work out the integer values that satisfy x squared minus 7x plus 11 is less than 0. So an integer value is a whole number. So it's not a decimal, not a fraction. Whole numbers like 1, 2, 3, 4, 5, 17, 21, 105, like that. So same as before, except this time we have to use a quadratic formula because we cannot easily find a way to solve this. Because the way to get 11 is by multiplying 1 and 11. 11 is a prime number, but there's no way of adding those numbers together in any way to get minus 7. And that should be a clue to you to use the quadratic formula. You can use the quadratic formula for any quadratic whatsoever, and it'll always give you solutions. But sometimes it's just easier to just do it in your head. It's much quicker than subbing in all the values. Another trick you can do is use your calculators. There is a function you calculate on how to solve quadratics, and I'll write an explanation how you can do that down below in the comments because this video to be more focused on the questions themselves. But that is something you can do. Let me know if you want me to make a video on how to use your calculator to the best of your abilities, and I'll be happy to go over that as well. So back to the question, I've subbed in all the values, and that gives us these two solutions, 7 plus root 5 over 2 or 7 minus root 5 over 2. And as decimals, those are the numbers that we get. So now we want to look at the part of the graph that's less than 0 this time. So that means that what part of the graph is below the x-axis? This will always be the x values that are greater than the smallest root and less than the greatest root. So it'll be in between those two values. And we know that our greatest root is 4.618, etc., and 2.381, etc., is our lowest root. So we know that the x values must be between those two. Now, because we're looking for the integer values, we know that the integers within these bounds is 3 and 4, as 2 is out of bounds and 5 is out of bounds. The only whole numbers between these two values is 3 and 4. So, quadratic simultaneous equations. Similar to normal linear quadratic simultaneous equations, except in a normal simultaneous equation question, you'd be adding or subtracting the two equations from each other. But with quadratic simultaneous equations, what you're doing here is just subbing one of the equations into the other one. So here you can see we've got x squared plus y squared equals 13 and x equals y minus 5. So what we can do is just sub in y minus 5 into that first equation instead of x, because we know that's what x equals. So then that gives us this. As you can see here, I've got it in factor form. We want to expand this out so we can get a quadratic equation. And once we do that, we can simplify it down to this. Now, because we can see that all of these values on the left-hand side are multiples of 2, I've just divided both sides by 2 just to make things easier. And that gives us y squared minus 5y plus 6 equals 0. Now, the next thing you want to do is you want to solve this. And you want to remember that whenever you're trying to solve a quadratic equation, you should always have the quadratic equation on one side and it must equal 0. So you can see at the top here, I've got y squared minus 10y plus 25 plus y squared equals 13. Yes, you can solve that, but it's so much harder to try and get it to equal 13. If you just simplify it down to something like this, which is always the case, you can always simplify it down to equal 0, then you can solve it much easier. Then that gives me y minus 3 and y minus 2. So the way I've done that is just I know that you need to add to give negative 5 and multiply to give 6. So minus 3 minus 5 gives you minus 5. Sorry, minus 3 minus 2 gives you minus 5. And minus 3 times minus 2 gives you 6. That's what I've got down here. And to get 0, y must either be 3 or 2. So that one of the factors will equal 0. Multiplying that by the other factor will then give the overall answer of 0. Now what you want to do is you want to sub that in to that linear equation that they've given you. You can sub it into the first one, but that's just so much harder, much longer. It's so much easier just sub it into the x equals y minus 5 equation. So you want to sub in both values to get the two values of x. Once you do that, you get x equals minus 2 or minus 3. You're going to remember that with these kind of questions, you're going to get two answers for y and two answers for x. Now, there are certain cases where you can only get one answer. So for example, if you think about the graph that I showed you at the start of y equals x squared, it only has one root. So we call it a repeated root because it only just touches the x-axis and goes back up. It's not two distinct points that are crossing the x-axis. So do be aware of that. Be aware of that. But it's most likely that they will have two answers. So thanks for watching. I hope this video was really helpful for you guys. And I know GCSE are soon, so do let me know if you have any urgent topics you want me to go over. I'll be happy to do that. Thanks for watching. Good luck for your GCSEs. And if you need anything, if you want to ask any questions, do that in the comments. I'll be happy to answer them. See you in the next one. Thanks for watching, guys.